Hi. Today we are going to discuss Bi-CMOS technology. So the previous sections we have discussed about the CMOS technologies, and today we are going to discuss about Bi-CMOS. So what is Bi-CMOS? It's a bipolar CMOS. It's a combined advantage of bipolar and CMOS. So first we discuss about the introductions. So bipolar technology was started in the year 1980s, and CMOS technology was started also in the mid of 1980s. And later in 1990 there was a crossover between bipolar and CMOS technology. So in Bi-CMOS technology, both MOS and bipolar devices are fabricated on the same chip. Previously bipolars are separate, CMOS are separate, and during the 90s it will be fabricated both MOS as well as CMOS into the same wafer. So Bi-CMOS technology, it's a combination of bipolar and CMOS technology, and CMOS technology it offers less power dissipation and smaller noise margin and higher packing density. But the bipolar technology is ensure high switching speed and input-output speed and good noise performance. So the main drawback of the Bi-CMOS technology is higher cost due to the added process complexity, because we need to fabricate CMOS, we need to fabricate the bipolar also. So this greater process complexity in Bi-CMOS result, it will increase the cost as well as it compared to the CMOS technology. So what are the characteristics of the CMOS technology? So the CMOS technology, the main advantages will be low power consumption and higher noise margin, higher packing density and high input impedance, because it's a low drive current, and due to that, and scalable threshold voltage. These are the advantages, and high delay load sensitivity and low output drive current. So it issue when driving large capacity load. So the CMOS will have a drawback of driving the large capacity load because of the low output current. And low transconductance, and where the transconductance GM is proportional to the input voltage VA, and bidirectional capability, drain and source can be interchangeable. And it's a nearly ideal switching device, and the gain will be less. So these are the characteristics of the CMOS. So what are the characteristics of the bipolar technology, BJT? So first one will be high switching speed, that is the major advantage of the bipolar, and higher current drive per unit area and also current higher gain, generally better noise performance and better high frequency characteristics. So improved I/O speed and high power dissipation. This is the drawback in the bipolar, its power dissipation will be high, and lower input impedance, because input impedance is less, and high packing density and low delay sensitivity to load and high transconductance, and essentially it is unidirectional, because bipolar can be unidirectional, but CMOS we can exchange either drain and source at anywhere. So now we can go for the combined advantage of the Bi-CMOS. We are combining the bipolar as well as the CMOS. So what are the advantages? Are improved speed over the purely CMOS technology, because we are combining with bipolar, the speed will be more. So another is lower power dissipation than purely bipolar technology, because bipolar is high power dissipation. When we are combining with CMOS, the power dissipation will be lesser than the CMOS. And the flexible IOs for high performance, and improved current drive over the CMOS, because the output current will be driven by the bipolar, so the output current will be high, so that we can drive the high larger capacity load also in the Bi-CMOS. And improved backing density over bipolar, and high input impedance, because input side will be a CMOS, so it will have high input impedance, and low output impedance, because output side we have a bipolar, so output impedance is less, so that the output current will be more, and high gain and low noise. So these are the advantages. And now we will see one Bi-CMOS inverter, how to fabricate a Bi-CMOS. Normally CMOS we have discussed in the previous classes. So it is a combination of the NMOS and PMOS. Here CMOS also there, bipolar is also there, and normally CMOS will be at the input stage and bipolar at the output stage only. So all the logic realizations will be done with the help of CMOS, and the output will be drive with bipolar technologies. You see that. So here once Bi-CMOS inverter we have designed. So here this combination of NMOS and PMOS will have a CMOS technology, and this output will be taken from the bipolar. So the output of this NMOS will be driven by this transistor Q1, and the output of this M2 will be driven by the transistor Q2. And if you see that when your input voltage is logic 0, what will happen? Output should be 1, because it is an inverter, output should be 1. So how we can get the logic 1 at the Vout? If input is logic 0, then it is an NMOS, so obviously this NMOS will be turned off. So this will be off. So it will off means obviously your Q1 it won't get any biasing, because the Z1 there won't be any voltage drop because this M1 is off, so that your Q1 will be off. When input is 0, this PMOS will be turned on, because applying 0, PMOS will be turned on. So what will happen? This VDD will be dropped on this Z2. So now this Q2 will be getting biased. Once the Q2 is getting biased, these two gets, so your VDD will come to the Vout. So your Vout equal to VDD. So when your input voltage is 0, your output voltage will be VDD. Suppose in the alternate case, your input voltage is at logic 1. So what will happen? So logic 1, obviously this PMOS will be turned off, so there won't be any drop in this Z2. So this Q2 will not be turned to on. So this VDD will not come to this Vout point. And on this bottom side, your NMOS transistor, when you apply logic 1, it will be turned on. So what will happen? There is a potential drop at the Z1. So Z1 will make the biasing of the Q1. So your once the Q1 is on, your Vout will be suddenly connected to the ground. So your output voltage will be reduces to 0. So while applying logic 1, output will be 0. Applying logic 0, output will be 1. So Bi-CMOS, it's a cross sections we see. So how the Bi-CMOS structure will be formed? So you see that, so this side a CMOS structure will be formed, this side a NMOS structure will be, a bipolar structure will be formed. So NMOS, CMOS means what? A combination of N plus and NMOS and PMOS. So here NMOS transistor is fabricated here, PMOS is fabricated here. As per the connections of the previous diagram, this will be connected. And here a bipolar will be emitter, base and collector. So that will be fabricated on the that side. So normally, but the bipolar, every layer under the epidoxia there is a P plus, N plus, N plus will be there. So what is this? This will be called as buried layer. This bottom of the substrates will be implanted with buried layer. That means the bottom will be highly doped. So what is the advantage of this buried layer is to reduce the substrate resistance. To reduce the substrate resistance, it will avoid the latch-up problems, because the latch-up problem will occur because of the substrate potential. By reducing the substrate resistance, so that substrate's potential will be less, so that the bipolar parasitics formed in the substrates will be less. So that is the reasons this buried layer will be implanted. And this becomes normal CMOS, so the NMOS and PMOS will be isolated by a field oxides, and here the bipolar will be fabricated. So this entire structure it becomes the Bi-CMOS. So what are the applications of Bi-CMOS? So normally these full custom ICs, ALU, barrel shifter, SRAM, DRAM, microprocessor, controllers, semi-custom ICs. So these are the advantages of the Bi-CMOS, or sorry, not advantages, applications of the Bi-CMOS. So when we compare the CMOS versus Bi-CMOS with different parameter, comparing the speed, this is the Bi-CMOS technology and this is the CMOS technology. So comparatively the speed will be high. So Bi-CMOS, the speed will be high comparing with CMOS. When you compare it with the delay, so Bi-CMOS will have the lower delay. Compare with CMOS technology, Bi-CMOS will have the lower delay. But when you compare with area, obviously the Bi-CMOS will have it occupies more area than CMOS. Because CMOS technology is only a NMOS and PMOS. Whereas the Bi-CMOS will need to have additional bipolar, so it occupies more space. So these are the comparisons between CMOS versus Bi-CMOS. Thank you.